This is lesson 13.2, arithmetic sequences, and you'll want to copy down these two formulas right here. You'll need this formula for explicit formula and this formula for the recursive formula. A sub 1 equals a number there. You'll actually have to plug in a number when you use that formula, but it'll be some number there that you plug in. So given a simple sequence like this, let's figure out how to plug into these formulas. So first thing you want to do is find the common difference. So any arithmetic sequence, if a sequence is arithmetic, it has what's called a common difference. And we use the variable d to describe the common difference. And so let's see what the common difference is here. You can see to get to the next term, I am subtracting, or I'm adding 7. At the next term, I'm adding 7. And I'm adding 7. So it looks like the common difference here, d would be equal to 7 because it's the same for all three terms, or all four terms, the common difference between each term. So I'm just going to plug into my formula to get my arithmetic, the explicit formula. So a sub n is the name of my explicit formula, equals a sub 1, which is the first term, negative 6, plus n minus 1. Now I want n in the formula, so I'm not trying to find a specific term, I'm trying to write the formula for the nth term. So I'll have an n in there. Times d, the common difference is 7 here, so times 7. So it's just a matter of simplifying this a little bit, and we'll get that to look a little bit better. If you distribute there, you get 7n minus 7. So a sub n equals 7n minus 7 minus 6 is minus 13. So that would be the explicit formula in simplest form. Recursive is possibly even easier. So it's just a matter of plugging in here. A sub n minus 1 is always going to be part of the explicit, of the recursive formula here. In this case, plus 7. And then one more part to this, I need to define what a sub 1 is. And a sub 1 in the first case, this is the first term, which is negative 6. So both of these define the recursive sequence. The a sub n defines the nth term, and the first term must be defined if you're doing a recursive sequence. Let's look at another one. So given this, can you write the formulas? Well, if you remember the two formulas there, I'm just going to plug in. So a sub n equals the first term, a sub 1, which is 13, plus n minus 1, times d. The common difference here seems to be negative 4, negative 4, negative 4. So I'm multiplying by negative 4 there. So I'm just going to simplify that expression. So a sub n equals negative 4n. And when I distribute there, I get positive 4 plus 13 is plus 17. So I've got my explicit formula. Recursive, you need to define the first term. Well, that's 13. The next term is going to be defined in terms of the previous term. Again, a sub n minus 1 is the previous term. We're adding a negative 4 or subtracting 4 here. That's our common difference, and that's the recursive formula. So a lot of this is plugging in. What's the 20th term? Now, if you wanted to, you could go 6, 11, and keep that pattern going and keep counting on your fingers until you get to the 20th term. But easy to make a mistake. Let's go ahead. Since this is arithmetic, let's use the formula. A sub n equals a sub 1 plus n minus 1 times d. So you get a sub 1 is 6 plus n minus 1. We're just going to keep it like that. Times d. Looks like the common difference is 5 here. So times 5. So a sub n equals 5n. See, when I distribute, I get negative 5 plus 6 is plus 1. So this is my formula for the nth term. It's the explicit formula. It's really easy to use the explicit formula. All you're going to do is plug in 20 for n into the explicit formula. So a sub 20, the 20th term, is equal to 5 times 20 plus 1, which is 101. So what's the 20th term? If I kept this pattern going, the 20th term would be 101. What are the second and third terms of this sequence? There's different ways to do this, but using the formula, it's kind of a neat use of the formula, and it's helpful, I think, to start thinking this way. I am going to use the formula, even though we could probably do this without using the formula. I'm going to use the formula. So a sub 1 n equals a sub 1 plus n minus 1 times d. So it's obvious to see what we plug in here for that first term. It's 30 plus, now n minus 1, I think we know what n is because this is the first term, this is the fourth term. So I think n in this case is going to be 4. So 4 minus 1 times a common difference of, I don't know that, which is bad because I really want to just only have one variable I don't know here, but I think I know a sub n because, again, in this problem, a sub n is the fourth term. When n is 4, right here, a sub n is actually 75. This is the fourth term, is 75. So we're not guessing at that. So we're going to solve this. It'll be subtract 30 from both sides. You get 45 equals 3 times d. Go ahead and divide by 3. You get 15 equals d. So our common difference is d. Once you find the common difference, I prefer to just add it to get to the next term. So this would be 30 plus 15 is 45, plus 15 is 60, and plus 15 is 75. So you can see that it definitely works. And that's probably the quickest way to do that. Okay, so this one, if you wanted to do it, is going to be the same as the last one. So let's look at the arithmetic mean. So this is kind of an easy concept with the arithmetic mean. So this guy is the arithmetic mean of these two numbers. And basically what that means is you're going to average those numbers to find the middle of the two numbers, and that'll be the arithmetic mean. So if you add up 10 plus 20, 10 plus 20, and divide by 2, that's how you average numbers. You get 30 divided by 2, which is 15. So that's the geometric or arithmetic mean between the two of those numbers. So you could actually solve a problem like this using arithmetic mean. It's kind of a sneaky way of doing things. So because this value is in the middle between those two numbers, and this is an arithmetic sequence, I can just find the arithmetic mean, or the average of those two numbers, 12 and 38. If I add them together and divide by 2, 12 plus 38 is 50. 50 divided by 2 is 25. So I know this is going to be 25 right here. Now again, I can just continue that here. So if I want to find the middle of these two numbers, I'm going to add them together and divide by 2. So you add them together, you get 37. 37 divided by 2 is 37 over 2. That'd be a fine way to write that, 37 over 2, or in other words, 18.5. And then the last two here, to find this arithmetic mean, you're going to average these two numbers. That's 50, that's 63. So 63 over 2 is 63 over 2, or I guess if you wanted to find that, that would be what? 31.5 you could write as well. So that's kind of a quick way of getting those missing numbers if you don't want to use the formulas as much. There's another formula. You need to memorize these, although we won't provide them on the test. But they're nice, handy to know for ACT sometimes, so forth. This finds the partial sum, or finds the sum of a whole sequence or series here. So usually when we use the word series, when we put plus signs in between. So you notice we have plus signs there. If we use the term sequence, we'll use commas to separate the terms. So arithmetic series or arithmetic sequence are very, very similar. They both have a arithmetic pattern, but a series is going to have plus signs in between the numbers. So the problem with this formula is I really need, like in this case, I can start plugging in and say S sub n equals n over 2. Well, I don't know what n is, so I'm just going to write n over 2 times a sub 1. I know the first term is 2. I know the last term, a sub n, is 62. I'm calling that my a sub n, is 62. The problem is I really don't know what this n is. So I want to find out n in the formula for this problem, and I can do that. It's kind of a sneaky technique we use, but once you've seen it once, it's easier to recreate the second time. If you use the original formula, a sub n equals a sub 1 plus n minus 1 times d. So if I plug into that formula using these numbers, I'm calling my 62 there an a sub n. And so if I say 62 equals 2 plus n minus 1 times d, the common difference here is obviously 4. We're adding 4 every time. So if I simplify that problem, I get 60 equals 4n minus 4. So let's see, so add 4, so 64 equals 4n. Divide by 4, that would be 16 equals n. So we get that is the 16th term. So no longer is that a sub n, that's a sub 16. And now we can plug in 16 right here into this equation, and we should get an answer. 8 times 64, and whatever that is in your calculator, that's going to be your answer. So we can find the sum of a sequence pretty quickly by plugging into a formula. Again, you want to use the same kind of technique here. So the first step, it's kind of a weird step, but we're using the a sub n equals a sub 1 plus n minus 1 times d formula. So we're plugging in, this is like our a sub n, this of course is our a sub 1. We just don't know what number term that is. So we're plugging in negative 90 equals 81 plus n minus 1 times the common difference of, it looks like we're doing, we are subtracting 9 each time, so negative 9. So if I solve that problem, I get negative 171 equals negative 9n plus 9. Subtract 9, negative 180, I like that, equals negative 9n. Divide by negative 9, you get n equals, let's see, 20. And so now we know that's really the 20th term. And so knowing that and going back and using this formula, the S sub n formula there, S sub 20 equals 20 over 2 divided by a sub 81, that's a sub 1, plus a sub 20 is negative 90. And so that you're going to get 10 times negative 9, or in other words, negative 90. The sum of all those terms together adds up to negative 90. And that's your lesson.